So today I am going to explain the experiment of amplitude modulation. Amplitude modulation is modulating or modifying or changing the amplitude of carrier signal with reference to modulating signal. So we have the modulating signal generator here whose frequency and amplitude can be adjusted using these two potentiometers, and the carrier generator is available here whose amplitude can be adjusted using this potentiometer. The output of modulating signal and carrier signal are to be given to the adder circuit so that the additions of amplitudes will take place. So to the input of adder, we have to connect the output of carrier signal, that is FC, to the FC input of adder, and the output of modulating signal is to be connected to the FM input of adder. Output of adder is to be connected to the input of tune circuit, which generates a fixed frequency or high frequency carrier signal, and its amplitude will be modified or modulated with respect to the addition of amplitudes of FM signal and FC signal. So let's observe this first. I am connecting the modulating signal to the FM input of adder and the carrier signal to the FC input of adder. Before we proceed, let's adjust the amplitude and frequency of modulating signal and amplitude of carrier signal. We have adjusted the frequency of modulating signal to 1 kHz and the amplitude of modulating signal to 1.04 or approximately 1 volt. The amplitude of carrier signal is adjusted approximately to 2 volts, while the frequency of carrier signal is fixed at 64 kHz and we cannot modify it. Now, with the amplitude of modulating signal equal to 1 volt and carrier signal equal to 2 volts, we had adjusted the modulation index equal to 0.5. So with this adjustment of modulating signal frequency and amplitude of carrier signal, let's move on to the observation of the modulated signal. Now we have connected FM and FC to the inputs of adder. Now the output of adder will be applied to the input of tuned circuit. Now the output of tuned circuit is a high frequency carrier, but its amplitude will be changed according to the input, that is addition of amplitude of modulating signal and carrier signal. We'll observe this modulated output with reference to modulating signal. The output or AM signal is observed at the output of the buffer. So here we can see on channel 2, the envelope of AM modulated signal is observed. This widely open portion is called as Vmax and this small open portion is called as Vmin. So using Vmax and Vmin, we can calculate the modulation index. This modulation index can be varied by varying the amplitude of modulating signal or amplitude of carrier signal. So modulation index decides the depth of modulation and whether the demodulated signal can be generated without distortion is dependent on the value of modulation index. Ideally, the modulation index is set between 0 to 1, but as we go on increasing the modulation index more than or above 1, we will find that there will be distortions in the modulated signal and the reconstructed signal will also be seen to have the distortions. Here also we can observe in the modulated signal, we can observe the distortions at the positive peaks as well as at the negative peaks. The signal or the Vmin has become approximately equal to 0. And this distortion in the modulated signal will also be transferred to the receiver side, which will make the demodulated signal to be distorted. So it is essential to adjust the modulating or modulation index by adjusting the amplitudes of the modulating signal and carrier signal so that we can see a distortion free modulated signal so as to generate a distortion free demodulated signal. Now this envelope of the modulating signal, we can observe that the edges of the modulated signal carry the information or the modulating signal, and on the receiver side this boundary of the modulated signal will be extracted to get back the original modulated signal. We can measure the modulation index using graphical method by measuring the voltages of Vmax and Vmin, and using the formula modulation index is equal to Vmax minus Vmin upon Vmax plus Vmin. So to measure the value of Vmax, we need to use cursor. Now for measuring, we have to select the source. We have connected the modulated signal to channel 2. So the source has to be selected as channel 2. Type has to be amplitude so that these horizontal cursors will be visible. And now we are adjusting the cursors at the top of the positive peak. Cursor 1 is adjusted at the top of the positive peak and cursor 2 is adjusted at the negative peak of the modulated signal. So this will give us the measurement of Vmax, that is the portion of the envelope which is widest open. And here we can measure Vmax, that is delta V. Here it is 3.72 volts. For measuring Vmin, we have to adjust the cursors at the minimum open portion of the envelope. So I am adjusting cursor 2 at this lower portion of Vmin, and cursor 1 is adjusted at the upper portion of the Vmin. And here the delta V indicates the value of Vmin, that is 640 millivolts. So by using the values of Vmax and Vmin, we can calculate the modulation index theoretically. Also we can calculate the modulation index using trapezoidal method, for which we need to use XY mode. Now in XY mode, we have to use the procedure as press utility, display and format to be XY. So here we can see the trapezoidal pattern. Amplitude of this larger side is measured, or it is indicating Vmax in the modulated signal, and this amplitude of the lower side of the trapezoid indicates Vmin in the modulated signal. So we have to measure this amplitude, which is denoted by letter A, and the smaller amplitude denoted by letter B. And the formula for calculation of modulation index is A minus B upon A plus B. To calculate the voltages, we have to measure, or we have to adjust the signal trapezoidal pattern such a way that we can measure the number of divisions that is covering multiplied by the scale factor. So here the number of divisions covered are approximately 0.2, 0.4, 0.6 or 0.7 multiplied by 1. So that will be 0.7 volts. And for the larger side of this, we will adjust it in such a way so that we can measure the number of divisions. And here we can see the number of divisions are 1, 2, 3, 3.8. So 3.8 into 1 volts will give us the value of A. So by using the formula A minus B upon A plus B, we can measure the modulation index using trapezoidal pattern. To the demodulation using simple diode detector circuit, the AM signal is to be connected to the input of diode in the diode detector circuit, and capacitor is to be connected in the circuit, which will charge and discharge to the positive going pulses in the AM signal. If we connect the output probe to the output at the capacitor C1, we can see at the channel 2, the demodulated signal is resembling with the modulating signal of the demodulated signal. Now I have connected another capacitor C2 in the circuit, and we can observe that the output demodulated signal has been distorted due to rate of change of charging and discharging of the capacitor. So by changing the value of resistance, I have now adjusted the RC time constant so that the distortions can be removed. So this is how the simple diode slope detector detects or demodulates the amplitude modulated signal. Now coming back, we'll see the spectrum of the modulated signal. I'm connecting the probe again to the AM signal, the AM modulated signal at channel 2. We'll go and observe the spectrum of this signal. To observe the spectrum, let's follow the procedure. Press FFT. We have connected the modulated signal to channel 2. So this source is already channel 2. Window is to be selected as Hanning, and adjust this highest peak at the center of the screen of the DSO. And to observe the sidebands properly, we need to zoom the spectrum. Let's zoom it by 10. So here we can observe that the center lobe indicates the carrier frequency, the power in the carrier frequency. The adjacent lobe or the upper side lobe is the USB upper side lobe, which is at FC plus FM frequency, and the lower side lobe is adjusted or spaced at FC minus FM frequency. Now to measure the bandwidth of this AM modulated spectrum, we have to press cursor. Then the source should be FFT, type should be frequency, because we are going to measure bandwidth. Now the cursors are to be adjusted at the peak of the side lobes. So here I am adjusting it at the peak of the lower side lobe or lower side band, and cursor 2 is adjusted at the peak of the upper side band. Now the difference between these two side bands is nothing but the bandwidth of the AM modulated signal, which is 2.1 kilohertz here, and theoretically the bandwidth of the AM modulated signal is twice the frequency of modulating signal. Initially we had adjusted the frequency of modulating signal to 1 kilohertz. So theoretical value of bandwidth will be double of 1 kilohertz, that is 2 kilohertz. So here we can see we have got approximately same bandwidth using this spectrum, that is 2.1 kilohertz.